Hello everyone, today I just want to introduce how to solve the hypothesis testing using the p-values, and then this is the review video. So thank you for joining us and thank you for watching this. So today I'm gonna analyze one scenario, which is the auto racing part. So we have a pit stop where we fix the new tires, fuel, or repairs during the car racing, and then we had one claim about from the pit crews that says that the mean pit stop time is less than 13 seconds, right? So here when you have the claim, so this is the mu is less than 13. And then it does not include the equal condition, so we have the hypothesis. Null hypothesis, mu is greater than equal to 13, and alternative is the mu is less than 13. And we have the random sample n as a 32, and then the sample mean is a 12.9. And we know about the population standard deviation 0.19, and then we have the alpha level as a 0.01. So this is the mathematical expression about the hypothesis testing scenario. And then what we have to analyze here is first we have to identify first the left tail test, because we have the alternative as the less than here. And then another thing is we know the population standard deviation. This gives us we're gonna use the z-test for the mean. So we're gonna have two things. The first thing is the left tail test, and second thing is the z-test. That's what we have. So let's move on to the StatCrunch. So this is StatCrunch we have. In the StatCrunch, let me just increase a little bit here. And in the z set, we have one sample with the summary. So that's what we have. So the sample mean is 12.9, that is x bar. And the standard deviation, this is 0.19. And then we have the sample size n as a 32. And then we have the sufficiently large number of sample size, which is greater than 30, so we can get it. And in the hypothesis testing, we have to control this one to the less than, and then we want to compare this one with the 13. And click the show critical values, and we have the significance level as a 0.0. So that's all the thing we have. Okay, click compute. So if you click compute, we have the output here. So we have the sample size as 32, and the sample mean as 12.9. We have the standard error, which is a sigma over square root of n. We get this, and then using this number, we calculate the z-step, which is negative 2.977, and then we get the critical value z that has the probability as a 0.01. So it means that when you draw the standardized normal curve like this, we have the critical value as a negative 2.326 something. And then this area is 0.01. And then we get the test statistics that belongs to here. This is negative 2.977. So it means that this z-stat belongs to the rejection region. So we reject no. Means that we have sufficient evidence to support the claim, because we have the claim as the alternative, right? So we're gonna support the claim. Is it good? And also we can get the p-value, which is the area from this part. Then this is given as a 0.0015, that is less than alpha. So we have very rare probabilities to get these samples according to our data. So it means that our null hypothesis is not probable, so we reject the null, and we have sufficient evidence to support the claim. Yeah, so this is how to use the StatCrunch to find out the hypothesis testing for the mean when sigma is known. Thank you.